Can Rolle's theorem be applied to the function on the interval ab, given here? Three conditions must be met. If Rolle's theorem can be applied, find all the values of c in the open interval ab such that f prime of c equals 0. The function is f of x equals the absolute value of the quantity x plus 2 minus 5. The interval is -6 to 2. The three conditions that need to be checked in order to see if Rolle's theorem can work are: the first condition, we have to make sure f is continuous. The second condition, you have to make sure f is differentiable. And the third condition is that f of a needs to be equal to f of b. And just by reasoning through this, this is an absolute value function. An absolute value function is in fact continuous. There are no holes in the graph. It's not a piecewise function, so it's not trying to meet up in two different places, something like this. The absolute value function is a continuous function. The next condition that we need to check is differentiability. Is f of x differentiable? Well, there are a lot of things to check for differentiability. There could be a hole in the graph. If you have a hole in the graph of the original function, then the function is not differentiable. If there's a vertical asymptote within this interval of the original function, then that graph is, or the function is not differentiable. If there is a sharp turn or a cusp or a vertical tangent line in this interval, then the first derivative, the original function is not differentiable. And as it turns out, we all know that the absolute value has got a sharp turn in it. The graph of this absolute value function looks something like this. And just by looking at this graph, you can see that there is a sharp turn right here at x equals -2. Which is in the given interval. Let's say you don't have the graph, or you forgot how to graph your translations of left 2 and down 5 and what the absolute value parent function looks like. How would you be able to tell that this function is not differentiable on this interval? Well, it's easier than you think. If you just look at the absolute value part, the absolute value of x plus 2, and you take what's on the inside, you take the argument of that, x plus 2 equals 0, you set it equal to 0 as I did here, and you solve it for x. This is where the sharp turn happens. So that means that since there is a sharp turn on this interval that was given to us, that this original function f of x is not differentiable. So Rolle's theorem cannot be applied.